Okay, in this video, we're gonna learn how to use worker pools in our count files project. So in the last time we used basically recursion to process all the folders and files, but we also used channels. So the problem with this approach is that it's gonna spawn ton of coroutines. Although we didn't experience any problem, it's not really stable. It will Gordons might eventually just get out of control, and mm, it's just gonna like crash and burn or something. So instead, we're gonna limit the coroutines that process these files and folders. To do that, we need to implement what's called a worker pools pattern. So let's take a look at that. So worker pools in Go are basically a queue of jobs and worker coroutines reading from that queue, a way to wait until all workers finish. Wait group, simple example. So we got a worker that takes ID and a job channel, and a wait group. So it just loops over the job and processes the job. Once it's done processing all the job, it marks itself as done. And in the main, we instantiate 4 workers, and we are creating a job channel, and we get hold of our wait group, and we create as many workers as there are worker count, and we just hand out the job channel to all the worker, and then so this is just creating some jobs and nothing special here. So after everything is done, we just call close jobs. So nothing is concurrently running except this part. So this part is independently running. I feel like this just launches the coroutines and then just moves on filling in some garbage data to the jobs channel, and then closes it. And then this is just waiting for all the coroutines to complete. So the generic pattern is creating the channel, looping over creating as many workers as there are worker count, and then ranging over all the jobs. So this is just creating some jobs and closing the jobs. So the worker just loops over the jobs channel and process the jobs. So this is the basic pattern. Another thing you can do is collecting results. Often you want a result channel too. So in our case, we're just collecting paths, right? Paths for the folders, paths for the files. So you can create a custom result struct, and you can create the custom result struct along with the jobs channel. So create the channel, and then when the worker is in the process of processing the folders or whatever thing, you can just send the result like this. And then you have one coroutine that just watches this results channel and does something with it. So we're building crawlers, right? So the common pattern is every job is just a path. So worker, this is already implementing the shit we want. Anyway, so that's the general worker pool pattern. Let's take this and try to use this in our counter count files project. All right, I have created a to-do list that is easy to follow to implement this worker pools pattern. I have also created I'm also using a single dispatcher um, pattern too. You will understand it why I'm using it in a bit. So let's go from scratch. So we need to init the go. Let's call this worker pools single dispatcher. I know this is long, but seems good enough name. All right. So we got the main go. So we got everything set up. So the first thing we want to do is create jobs channel, results channel, and worker count. Let's create jobs channel. So jobs are just, I believe, paths of string. So this the jobs channel, and I need to create a result. So results, it's a type of struct that holds new dirs. So every time the workers find directories, they're going to push the result to the results object. And worker count. Let's say our worker count is 4. So we need to create as many worker as worker count. So we can just use for loop and range over worker count and create workers. Okay, so these guys jobs is just looping over the jobs channel. So for range jobs, okay, so the first job, let's say jobs channel is a directory. Let's use my V drive. We also need to track. Okay, so range over the jobs, get the entries. So we got a job, and now we need to range over it. So we just need to use the OS read dir and use the job. So job is going to be just path, and this gives us entries and error. So if we get error, we just send. Okay, we need to create a results channels too. So results make results. So we just send just empty result. So we send empty result if the um, so we read a path, and if we get an error, we just send empty result. So this just indicates that we processed the path. And then we just need to range over the entries. Var entry range entries. So we just need to check if the entry is directory. If entry okay, entries dir entry, what do we get? Probably we get an index or something, all right? If entry is dir. So if the entry is dir, we also need to keep we need to create an array of directories, and we need to add these whenever we find directories. We need to append the directories to that newly created uh, directory array. So we don't want to create that array inside the for loop, maybe outside here. So let's create dir. Okay, let's create a new dir. New dirs is okay. So let's use append new dirs entry name. Okay. So we got some error. A value of type is not used. We need to append the full path. I'm gonna fix this error in a bit, but before that we need to get hold of full path. So we know how to get the full path. So this is it. So join the path with the entry name, basically, right? So just get all of the job and so join it, file path, join the job and entry name. So we get the new DIRs after joining of so we are essentially just looping over the entries. We find the folders and then we just add it to the new DIRs array. So after we are done with the entries, for the regular, we're just gonna let's also create files channel. Okay, if the entry is just a regular file, we push it to file channel, get rid of the full path, and just skip this loop. So after we are done with the outer loop, we send the result to the results channel. So we need to create the result object. New DIRs, new DIRs. Cool. Hello. Um, looks like we are out of scope to use this variable or something. Okay, let's maybe call this new folders or something, because we are using the same things. New folders. All right, so we are getting the declare not used. Says new folders is declared but not used. Why? Because inside the if block you are creating a new variable named new folder that shadows the outer one. So go sees, then later, which is effectively we have outer variable and we are creating a new, the outer is never used. You want, okay. So we just need to get rid of that. So essentially, if I used this syntax, kind of creates a new folders inside of this block, even though I didn't want it to create like that. All right, so now all the workers, it gives us the result. So make sure to construct a path. Okay, we need a way to know how many jobs are active and how many are pending. So why? Because if we have no active and no pending jobs, we can exit whatever loop we are using. Active is the number of folders being processed at the moment. Pending is the path still not being processed. So the reason I'm using the active and pending variables is because I'm going to be using some loops and I want to exit out of that loops. So let's create those variables. So active, initially it's going to be like 0. Pending, so essentially jobs is the pending. Let's add pending. Pending is, let's create a pending here. Pending is array of string. Let's append pending. Okay. So we're gonna use a single dispatcher here. This dispatcher's job is just managing everything. So we got a for loop, outer for loop, and another for loop. Okay. So we got a for loop that checks if the active. So okay, since we are not using buffered channels, if these like workers send some stuff to the channel, and if there is no one active to receive and process the job, it's gonna get just blocked. So we only um keep uh like at most like jobs, like we only keep 4 jobs active at the time. We only process four things at a time. So worker count and process. Okay, what pending? Um, so we're just gonna like use this for loop to like just send jobs to the jobs channel or whatever. So we only loop if the length of the pending is greater than 0. So then we get the first job from the pending, and then the pending becomes pending. Okay, the pending becomes everything except the first item, and then we pass this to jobs channel. Pass the first job. Okay, that's pretty much it. So we send like 4 jobs to the workers. These workers send the results back. Okay, we get the results from the results channel. So when we get the results, we want to increase the pending. We want to append the directories we found from the result. So let's get the new folders or something. Results channel. Okay, now we got the new folder. We got an instance of results. So we add those to pending, append pending to new folders. new dars. So it's kind of looking weird. So let's just call this result. And then we add that to the pending. So if active is 0 and pending is also 0. Okay, we need to get the length of pending. Length of pending is 0. We close the job channel. All right, let's I mean, looks like it could work, right? So let's look at the code. So we got the job channels, results channel, files channel. We get active and pending and jobs. So we immediately append the initial path to the pending, and then we have 4 workers. So these workers are just looping over, just checking the jobs channel, and for every job they read the directory, get the entries, and just their job is to somehow find directories and create a results object and push it to results channel. So we have one, like in the main we have for loop. That job is just pushing jobs to jobs channel. So eventually active and pending becomes 0. So um, okay. So eventually it's active and pending becomes 0, and we exit the for loop, I think. So active is 0. Currently the active is 0. So length is 1, and sends the path to the jobs channel. Okay, and we decrease the pending here, and result. So we get the result. When we get the result, okay, so before we send the job to the jobs channel, I want to increase active, and then when we get the result, I want to decrease the active to, I want to decrease active. And then I want to append the pending array. That's pretty much it. I want to do this over and over again. And then just return if active and pending is 0. Close job and then just return. Okay, that's pretty much it. Let's see if it works. Okay, we got a deadlock. Why? So what's the error? 18. So we got a deadlock at 18, and there's a send channel. Send channel. So it can't send. Okay, what the hell? Uh, Jobs. So there's no one. So when we do this, there is no one to receive at the moment. What the hell? So when I send it, so this gets blocked here, and there is no one to receive it. Okay, so we are getting we're getting the first job from the pending and pushing it to jobs channel. So we're doing the same thing, and we're also doing the same thing here. So we don't want to do. I'm just gonna comment that out. So let's see. There is no channel operation that should block. Okay, we got another like channel block. I think here. Probably here, right? Let's see if we have uh okay, we got some blocks. So we got 9 coroutines. Every coroutine's getting blocked. Like, okay, first coroutine is blocked on the send channel 57. So this tries to send to the jobs channel, but we already have a coroutine that is looking at the jobs channel, so it should receive it, right? All right, so we were missing some logs, and I did not I had a channel and I was pushing some values into the channels, but I was not reading the value from the channel, so it got blocked. And yeah, just use the entry name here. That's pretty much it, right? There's nothing wrong. So these are the folders it discovered. Pretty nice. So one thing you can do is concurrently just launch this sending operation. So you can do go func, just create an anonymous function and just do it like this. So this will just independently create go routines. Like it's gonna like create at most 4 go routines. That's pretty much it. It's pretty fast on the V drive. I also changed the path, I think. Before I was using like this. So I'm just running it on the C drive. Okay, this is pretty fast. All right, that's pretty much it. Like you can now do whatever you want with the you can get the files and do whatever you want with the file. Just create whatever channels you want and just send values to the channel and process those values from the channel. So that's pretty much it. So so we created channels. The one thing is that one thing to note is that I am using unbuffered channels, and I'm also my workers, like they are just consumers. So earlier what I did is just I created a worker that would just range over the jobs, and then when they discovered jobs, they would push the uh, directories to the jobs channel again. So what it made is that the workers were both consumers and producers. So we got in a deadlock. So the solution was to create a buffered channel, and as um as I as I ran this in the C drive, the buffer usually gets filled really quickly. The solution I came up was just increasing the buffer size, like a million, like I had like million buffers. So which is a lot, I think. So the the solution I settled on is just making it work using just the unbuffered channel. I think this is the most like elegant solution in my opinion. This doesn't create ton of routines, and yeah, that's pretty much it. Also uses the unbuffered channels, which I like. So we looked at recursively finding folders and channels. Okay, let's just try to count files. So that's what we're in right. Let's call this file counter. So initially it's just 0, but as soon as we find regular files, if uh, if entry dot is regular, if it's just regular, I also like continued when I add error or something. Anyway, when it's just a regular file, I'm going to increase the file counter. That's pretty much it. And then at the end, also I'm not even using the weight groups. Weight groups were pain in the ass. I think yeah, it's because the terminal is just garbage. I need to use the same solution. Okay, wait a minute. Unreachable code. My bad. Okay, that's because we return out of the main function. I mean, the only way to like get out of this for loop is if we use some condition, right? Um, like I don't know. Since this is a very simple program, um, I could just put the code here. So this is my queue. When active is 0 and pending is 0, my program is pretty much done. Okay, there we go. So there are like what? Very big number, 1.5 million files on my C drive. Anyway, I'm gonna link this source code in the description. You can check it. And that's pretty much it for this video.